Chapter 8. This is our section 8.5, working with the properties of logarithms. So what you have here on the screen is you see the product property, the quotient property, and the power property. And what these allow you to do is expand and contract logarithms, that's the vocabulary for it, in order to simplify and or solve, depending. So the equations here on the left-hand side show condensed logarithms, and on the right-hand side they show expanded logarithms. So when you see that you can factor the object of the logarithm, then you can separate it into two logarithms that are added together, and you'll notice that the base of the logarithm does not change. When they're divided, you can put this into two logarithms that are being subtracted from each other. And then when you have an object that is being taken to a power, you can make that exponent a coefficient in front of the logarithm. So these have a great parallel to the rules that you had for exponents, which makes sense, right? When we had two items with the same base that were being multiplied, we added the exponents. When we were dividing items with the same base, we subtracted the exponents. And when we took a power to a power, we multiplied the exponents. So this has a similarity, and that again reflects the relationship that logarithms have with exponents or powers. Okay, so working with simplifying these fellows by expanding and or contracting. In this case, we have condensed logarithms and we're going to expand. Later we'll take expanded logarithms and contract. If I just wanted to simplify this, I can take, you see I have an exponent, I can make it a coefficient. 3 times log base 2 of 4. And log base 2 of 4 is, right, 4 is 2 to the second power, so that would be equal to 2. 3 times 2 would be equal to 6. Okay, and over here I can have 3 times the log, this is common logarithm, so it's logarithm base 10 of 0.01. Now 0.01 is 10 to the negative 2 power, so this would be 3 times negative 2, which would be equal to 6. Okay, some part of your homework involves, again, testing your understanding of this idea by supplying you with values of logarithms and having you use those properties to try to simplify. So what you're looking at is, how can I make the object of the logarithm using the supplied items? So they didn't give me logarithm of 3, they gave me log 15 and log 5, but 3 is 15 divided by 5, so I could say this is log of 15 divided by 5. And if I expand this, that's going to be log of 15 minus log of 5. And that would be 1.176 from this value minus 0.699. And that's going to equal 7.477. Okay. If we have log 75, again that's not supplied, but 5 times 15, right, is 75, so this would be log of 15 times 5. That would be equal to log of 15 plus log of 5. So that would be 1.176 plus 0.699, and that would be equal to, let's see, 5, 7, 1.875. All right, and log of 1 over 15, well, that would be equal to log of 1 minus log of 15. When log base 10 of 1 is 10 to the 0 power, so that would be 0 minus 1.176, which would be equal to negative 1.176. Okay, so your task in this type of homework is to figure out how you can make the object of the supplied logarithm, or the logarithm in your problem, with the supplied values that they've given you. Okay, so this is an example of working that way. So if we expand this item, I can break up all the parts that are being multiplied, and I can turn them into individual logarithms that are being added. So I'll have natural log of 3 plus natural log of x plus natural log of y cubed. And the last thing I have to do is take this exponent and make it a coefficient. Nothing else changes in the other logarithms. So this would become 3 times the natural log of y. And now this would be fully expanded. Okay, this is very simple. It's just two items, 22 times x. I'll have natural log of 22 plus the natural log of x. And that's all there is to that one. This one's a little more complicated. This is log base 2 of 4x to the 1/2 power. So I can take the exponent and make it a coefficient. So that'd be 1/2 times log base 2 of 4x. Now I can break apart the 4 and the x, so this is going to be 1/2 times log base 2 of 4 plus log base 2 of x. And log base 2 of 4 is 2. Right? Because 2 to the second power is equal to 4. So that's 2 plus log base 2 of x. And then finally, if I distribute the 1/2, 1/2 times 2 is 1, plus 1/2 times log base 2 of x. And this has been fully simplified now. Okay, so sometimes there are very few steps. Sometimes there are a couple steps, and sometimes it takes several steps to work through to the very end. Right, now that was expanding. Now we're going to take expanded logarithms and we're going to condense them. So again, if I find coefficients, right, so what we want to do is we want to get rid of coefficients, they become exponents, and then adding would become multiplication and subtraction would become division. So the first thing I'm going to do is just take care of the coefficient, natural log of 20 plus the natural log of 1/2 squared plus the natural log of x. And then these items will all get multiplied together, so it'll be natural log of 20 times 1/2 squared, which would be 1/4, times x. And 20 times 1/4 is 5. So this becomes just the natural log of 5x when we condense it all together. Okay, again, subtraction is going to become division. This is going to be log base 5 of 8 divided by 12. And I want to simplify the 8/12, so this is going to be log base 5 by factoring a 4 out of that of 2/3. Okay, so when you're expanding, right, you're taking items that are being multiplied or divided and you're pulling them apart into either addition or subtraction, and you're taking exponents and making them coefficients. And when you're condensing, you're doing the reverse. You're taking coefficients and making them exponents, and you're taking items that are being added, and then what you do is you multiply the objects there. Okay, here's some more. What I would first do in this problem, because it's a little complicated, is I distribute the 3. So this would be 3 natural log of 3 minus 3 natural log of x. So we'll have that. Plus, over here, division or subtraction would become division, right? That would become natural log of x divided by 9. Right? When I go ahead and I go through with simplifying this stuff, the 3's are going to become exponents, so it's going to become natural log of 3 cubed minus natural log of x cubed, right, these guys, plus the natural log of x over 9. Now 3 cubed is 27, so this would become 27 over x cubed, right, and this plus would make it multiplied times x over 9. Right? So what I did in this step is I took the subtraction, I made it division here, and then this addition becomes multiplication. And when I simplify, 9 goes into 27 3 times, so when I factor the 9 out, that happens. I take this x and I take it out of those 3, and I just end up with x squared. Okay, so there's condensed and then simplified. And then this is a problem I did on the previous page, so I won't redo it. The last thing we want to do here in 8.5 is deal with the change of base formula. Now the change of base formula allows you to use either natural log or common log to do a logarithm of any base. So you can see log base c of u can be log base b of u divided by log base b of c. And all this means, this log base b here, is the same logarithm, right? The logarithm of the same base. So you could take the logarithm base 10 of the object of the log divided by the base of the log. Okay, and you could do the same with natural log. So if you want to, that allows you then to do log base 3 in this case, using your calculator very simply. So you'd simply do log of 16 divided by log of 3. You could also do natural log of 16 divided by natural log of 3, and you'll get the same result. Okay, and in this case we'd have log base, natural log of 4/15 divided by log of 2. So common log of 4/15 divided by common log of 2. Equally, we could do natural log of 4/15 divided by natural log of 2, whichever you prefer. It doesn't make any difference. You'll get the same result when you create this ratio. Okay, but that allows you to take the two keys on your keyboard, logarithm and natural logarithm, and perform logarithms of any base. And that's it for 8.5.